All right. Now, also why, well, I've got this one up here. Let me note two other things here, and that are talk about the intercepts. By intercepts, what we mean are those points where the graph crosses the x or the y-axis. So an intercept is where it crosses an axis. Guess what the x-intercept is? Where it crosses the x-axis. An x-intercept is where it intercepts the x-axis, or where it crosses, where the graph crosses the x-axis. And then the y-intercept is the reverse of that, of course, where it crosses the y-axis. Okay, very simple concept there. So in this case, where are my intercepts? My x-intercept is right here. And my y-intercept just happens to be right there. Just where it crosses the axis, the particular axis, okay? Now we might note the ordered pair here, because that's what they will want for when you give an x, if it asks for an x-intercept, they'll want the ordered pair. And what's the ordered pair here? This one is 4, 0. What about the y-intercept? Well, it's -6, but the ordered pair is 0, -6, okay? And so you kind of see the relationship there. The x-intercept's 4, 0, the y-intercept's 0, -6, because, let me go back, I've already erased it, but let me recall here. Our other graph, it was x plus 2y equals 8. And if you look back there, I had this and this. Wasn't that what the equation graph looked like there? Well, if you'll notice there, the x-intercept is 8, 0. And the y-intercept is 0, 4. I bring that one up because focus on the x-intercepts for just a moment. Do you notice anything common about the x-intercepts in both equations there? It's this right here. In both equations, both graphs, the x-intercept, I have a y value of 0. Now look at the y-intercepts and tell me what's common about the y-intercepts. I have a 0 there, but where is it? It's in the x. Okay. So that's significant because when I don't have the graph, when I just have the equation, and I'm wanting the x-intercept and the y-intercept, those two facts are very important. On the x-intercept, the y value is always 0, and on the y-intercept, the x value is always 0. All right? Keep that in mind. Because here's what I'm going to do next. Let's say I have 2x minus 3y equals 12. And my goal here is to find the intercepts. Well, I just don't happen to have a table at hand, so I'm just pretty much going from scratch here, trying to find the intercepts. But what I can note here, let's start with the x-intercept. I know that on the x-intercept, what's always true? Y is always 0. Yeah. So to find the x-intercept, set y equal to 0 and solve. since I know y has to be 0 for my x-intercept, right? We just talked about that. Set y equal to 0 and solve. In other words, take this equation here, set y to be 0, because that's what the y-intercept has. The x-intercept has. It has y equals 0. So if I do that, well, that's going to turn that to 0, right? 3 times 0 is 0, so it's just 2x equals 12 divided by 2, and we get x is 6. So we find the x part of the x-intercept. The x-intercept here, like I said, you want an x comma y for the x. It's a point, the x-intercept is. So I want an x comma y. What is it? I found x to be 6, and we always know for the x-intercept the y is 0. So there's our x-intercept. Well, guess what? By the y-intercept, yeah, you reverse it. To find the y-intercept, you set x to be 0. And solve for y. Same exact thing, just reverse it. If you want to find the y-intercept, set x to be 0. Back in the original equation here, just letting x be 0, solving that out. Well, these, of course, are the nice ones that we had before. Yeah, these are zeros, so negative 3y equals 12. Divide by negative 3, and we get y equals negative 4. So what's my y-intercept? The ordered pair, that is 0, negative 4. X is 0, y is negative 4. Okay? Is that okay? All right. Now, here's an added bonus here. Let me put these, probably have enough room over there, but let me write these right here. All right, so my intercepts are 6, 0, and 0, negative 4. Well, here's the thing. Now, if I think about graph of that, do you know anything about the graph of 2x minus 3y? Well, I know the intercepts are 6, 0, and 0, negative 4, but what else do I know about that equation? What shape does it have? It's a line, isn't it? Because it's x to the first, y to the first. Those always will be lines. And I know these 2 points are on that line, so let's put those there. 6 and 0. It's on the x-axis. 0, negative 4. That's on the y-axis. Well, if this is going to be a line, don't those 2 points pretty well determine the line? Yeah. It's enough, if you know it's a line, it's enough to find 2 points to graph a line. And if your intercepts are 2 distinct points, that's enough to graph our linear equations in 2 variables. Because there you go. There's no other way to do a line except through those 2 points. So this is another method to graphing lines. In essence, it's the same thing, but we're not actually officially doing a table. I mean, you can put them in a table if you like. Some people do that, and that's fine. But yeah, just find the intercepts, and if they're 2 different points, yeah, you do have enough there to go on to graph it. Okay? All right. So, everybody got that one? Let's graph another couple here. Two x minus 5y equals negative 4. Let's find the intercepts and graph that equation. All right. Okay, well, again, just highlighting. To find the X-intercept, what do? Set y to be 0. Yeah, to find an intercept, whatever intercept it is, you set the other one to 0. If you find the X-intercept, you set y to be 0. If you find the y-intercept, set x equal to 0. So the X-intercept, yeah, I'm setting y to be 0. So that gets me 2x minus 5 times 0 equals negative 4. That zeroes out, so 2x equals negative 4. Divide by 2, you got x is negative 2. All right. So that is the X-intercept. I would definitely recommend that you write it as an ordered pair. That's the proper way to write it. What is it? Negative 2 comma 0. I got the principle. Found x is negative 2. I set y to be 0, so negative 2, 0 is the combination there. All right? The y-intercept then is, we set x to be 0. 2 times 0 minus 5y equals negative 4. That zeroes out, and that's, again, be sure to bring down that negative 5. Y equals negative 4. Divide by negative 5. What do we get? We got a negative divided by negative. It's a positive 4/5 or 0.8, however you prefer there. So the y-intercept would be x is 0, y is 4/5. How about that? Okay with that? So let's graph our equation now, because I have 2 points. Negative 2, 0. And 0, 4/5. That's 1, then 4/5, 0.8. It's right about there. Graph those fractions. There's our line, 2 points. Got it. Okay? Let me do this one other one, because it has a little bit of a wrinkle in it. Problem we run into. Same thing. X plus 2y, though, equals 0. Run into a slight problem here. If I go with my X-intercept, set y to be 0, I get x to be 0. So I get 0, 0. If I go for the y-intercept, where x is 0, I get 2y equals 0. What does that mean y is? 0 divided by 2? What's that? 0. So I get 0, 0 also, right? Found x is 0 and y is 0. I found y is 0 and x is 0. That's kind of circular there, but all right, here's the problem we run into. Remember we said equations, you have to have 2 points. If it's a line, you need 2 points. 0, 0, which, by the way, something else, I think the book actually asks about this maybe. This point here, which is right here, right in the middle, is also known as the origin, and its coordinates are 0, 0, if they ask about that. The origin is the point right in the middle there, 0, comma 0. But in this case, we've got 0, 0, and then we've got 0, 0. Officially, how many points do I have here? I have 1 point, one single point. I need how many points to do a line? I need 2. So if this method right here gives me only one solution. So that's why I was saying, as long as these are two distinct solutions, you know, those are enough to graph. However, if it's just one, if you get the 0, 0 in both cases there, you still need another point. How do we get another one? Well, think about it. Really what I've got here is I've got, if I think of my table, I've got 0, 0 on my table. I need another value there. What other value do I need? Whatever value you want to choose there. Let's go with x is 1. We just need some other x value with some other y value, right? So it's for our choosing. I can do x is 1. If I don't like that point, then I can go to another point. I might want another point here, but you just need choose some other value besides x is 0 and y is 0. So let's choose x is 1. If x is 1, what's the y value goes with it? Well, just plug it in, right? Minus 1, 2y equals minus 1, divided by 2, y is negative a half. Now, if you don't like having a fraction there, well, choose x to be 2, and you can make the table as big as you want it there. If x is 2, then we get another point there just to kind of verify. We get a negative 1. So yeah, it's just coming up with another point, or more if you like, but that'll give us enough here to go on. X is 1, y is negative a half. It's right there. X is 2, y is negative 1. It's right there. So first one was enough, but anyway, okay. So that's how you'd handle something like that. Okay? And there's actually another way we'll do this one at a later date. Okay? Questions or concerns?